Petroleum compounds and their interaction with water. Hi, we're going to talk about how petroleum compounds interact with water and how this interaction affects the environment. Understanding the chemistry behind this helps us know why oil spills are so harmful and hard to clean. Understanding petroleum complexity. Petroleum is not a single substance. It contains thousands of different compounds. Most are hydrocarbons, combined with resins, asphalts, and heteroatoms. The main challenge is that the hydrocarbons are non-polar and water is polar. This difference explains why oil and water don't mix. It also explains why some compounds dissolve into water. Some evaporate into the air and others stay in the environment for years.
Now, there are four main petroleum compound groups. There are the saturates like methane, hexane, and cyclohexane. There are aromatics like benzene, toluene, and PAS, such as naphthalene. There are resins, which are polarizable and act like natural surfactants. And there are also asphaltanes, large and complex molecules that stabilize emulsion. Additionally, there are some specific toxic substances like hydrogen sulfide, naphthenic acids, and trace metals that can accumulate in food chains. Now, when it comes to the molecular structure and polarity, their molecular structure explains their behavior. Methane is tetrahedral and nonpolar. Hexane is a zigzag chain and also nonpolar. Benzene is a planar ring with delocalized electrons, which is overall nonpolar. BTEX compounds are slightly polar, so they are able to dissolve a bit in water. And finally, naphthenic acids are polar. Additionally, asphaltenes and amphylics uh, have both polar and nonpolar parts.
Physical properties and thermomolecular forces. Hydrocarbon properties. The hydrocarbons have low polarity, so they don't mix with water. They are less dense and float, and the viscosity varies from the gasoline to heavy bitumen. Water is highly polar and has strong hydrogen bonding. Oil molecules only have London dispersion force, while water molecules stick strongly together. This separation explains why they don't mix. Both asphaltanes and resin can act as surfactants, forming emulsions like chocolate mousse that are very hard to clean. Environmental toxicity and impact. Some of these compounds are very toxic. BTEX, especially benzone, is a carcinogen and affects the nervous system. PACs are proven carcinogen and paying sediment for decades. Naphthenic acid and are toxic to fish, especially eggs and larvae. Hydrogen sulfide is a deadly gas at just 50 ppm. Light compounds dissolve or evaporate quickly, while heavy compounds cause ecosystem and kill wildlife.
For the separation and cleanup methods, cleaning spills depends on the chemistry. Gravity and epi separators for free oil, skimmers, flotation, and centrifuges for dispersed droplets, ciphers plus heat or pH to break emulsions, and membranes, activated carbon or bioremediation for dissolver residues.
Real-world applications. One clear case in the Keystone Pipeline spill in Kansas in December 2022, when 2.7 million liters of oil leaked into Mile Creek. It became the largest onshore oil spill in the US history. It seriously polluted water and soil and took months to clean. This shows how knowing the composition of petroleum helps guide the cleanup process.
Critical reflection questions. Hydrocarbons are organic molecules made of carbon and hydrogen. They are non-polar while water is polar, which is the interseparate. Their behavior depends on density, viscosity, and solubility and volatility. Understanding these properties help choose the right cleanup method. Environmental justice and future consideration. This goes beyond chemistry. It's also about human rights. Communities affected by spill often lose access to clean water. Some compounds last for generations, affecting both ecosystem and people. If we understand this interaction, we can prevent spills and design better environment protection strategies.
Here's our collaboration table showing how each member contributed to this project. And there are the sources we used for this video, this project.
And that's all. Thank you for all, teacher.